Hello, so today we are going to do this problem which is part of Leetcode Daily Challenge. Today is a special day for me personally because I just hit the milestone of 200 streak. But that aside, let's jump into the problem. So insert interval. So the problem says we have a list of non-overlapping intervals where each interval has the start and the end position, and they are sorted in ascending order by the start value, so that's good. And we get a new interval that we want to insert into this list. And so we want to insert it in a way that we maintain the sorting order. So we want to keep the list sorted in ascending order after adding this new interval. And so what we want to return at the end is just the list of intervals after inserting a new interval in sorted order by start time. So that's the problem. Now, if we take a look at the first example here, 2, 5, you can see it's 2 is within 1 and 5 is just before this one, right? So you can see 2, 5 overlaps with 1, 3, so we need to merge. That's what the problem says here, is we need to merge if we need to. So if they overlap, we need to merge. The list of intervals needs to be kept non-overlapping. Okay, so here we need to merge 1 and 3 with 2, 5. So that gives us 1, 5. That's the merge, and then 6, 9 the second one. So that's roughly the idea. The number of intervals is 10 to the power of 4. It's already sorted, which means we should take advantage of that. So let's see how we can solve it. Okay, so let's see how we can solve this. So this is the example that we have. I will go with the simplest approach, and then maybe do other videos for other approaches, because this problem can be solved in multiple ways. But the first thing to think about here is, what are the different cases that we can have? Well, we could have either no overlap, right, at all, or we could have an overlap, right? Now, if there is no overlap, then this can be something like, maybe the new interval, let's call it Ni, can be to the left of all the other intervals. So let's say this is our other intervals. The other case is it can be to the right of all the other overlapping intervals. So let me just move this down. So the other case is we can have all the other intervals here and have our interval to the right here, our new interval to the right. Okay, so the third last one is it can be in between in between two set of intervals. So maybe we have red is the existing intervals, so maybe we have the existing intervals like this, and then we have our interval is in between when we insert in order, and then the other ones are after that, or maybe there is nothing. It depends, right? So that's also another possibility. But it can be only one of this can be like 1 to whatever number, and this is similar, right? And these are the only possible cases for no overlap. For overlap, it can be either overlap with one interval or overlap with multiple. So either with one interval, or it can be with multiple interval, right? Examples. So let's say with a one interval, it can be maybe we have the existing intervals are 1, 3, 4, 7, and the new interval, let's say, is maybe this is 6 instead. So 6, 7, and the new interval maybe is 2, 2, 3, right? Then the overlap is just between these two, and so the result needs to be 1, 3, and then 6, 7. Okay, so that's an example of an overlap with one interval. We can also have an overlap with multiple. So let's say maybe we have 1, 3, we have, let's say, 4, 6, 7, 8, and then 9, maybe 13. And let's say the new interval maybe is 2 all the way up to 8. Okay, then in this case, this one, our interval here overlaps with all three. And so the result needs to be 1 all the way to 8, and then 9, 13. So that's also a possibility, okay? So if we try to do this case by case, it's going to be cumbersome because we'd have to do all three for the no overlap, the different cases for the overlap. So an easier way is to think about it as just overlap or no overlap, right? How do we handle it? And so one thing you think about is, well, if we take the intervals that we have and break them down into left of the new intervals, right? So all those smaller than the new intervals that don't overlap to the left, and all those bigger than it that don't overlap to the right. And we can fill those two intervals easily, right? I'll explain how. Once we do this, then we can either check if there is an overlap, do something, but if there is no overlap, it should be pretty easy to just do left plus the new interval, a list of the new interval, plus right, because we know this is all those smaller that don't overlap with the new interval, this is all those bigger that don't overlap, and we know there is no overlap, and so we can just add them up and then return them, right? But if there is an overlap, then all we need to do, we don't care how many it overlaps with, how many our new interval overlaps with. We only care about the first one and the last one in the overlap, and we will take the smallest between the start of the first one of the overlap and the start of our new interval, and between the last and the last one. Even if it was just one interval, we'll just compare with the first and last of the same interval, right? So if it was, let's say, 1, 3, 6, 8, and our interval is 2, 3, right? So we'll just find that there is an overlap only between this one and this one, and we'll just compare the first overlap is the same, so we'll just compare between these two, and then the second one we'll just compare between these two, right? And so if we do it this way, we can abstract over how many overlaps we have and just take care of take the first overlap, take the last overlap, and compare the start and end. The no overlap case is pretty simple. And so how do we do this? So here, well, we just need to find the first overlap interval and the last overlap interval. Once we found those, then the start of the interval we want to add, let me just move this down a little bit. Then the start of the interval we want to add is going to be, needs to be the min between the first overlap, right? So the min between the first overlap here and our own start, okay? So it's just the first overlap start, which is 0, and our starting position, the new interval start. So let's just call it new interval start is just new interval position 0, and the end is going to be just the max. So this is the merged interval for the overlap. So it's going to be the max of the last overlap ending position, right? So that's what we want to do, the last overlap ending position and our new interval ending position. Ending position is 1, and the new interval ending position, which is 1. So these are the new merged intervals. So in this case, this is the interval that we will get 1, 8. In the case of one interval, it's going to be the 1, 3 interval, okay? And so we just need to add that to the result, right? And so how do we do it? Well, we can just return the left, because we know it's those that are smaller than the interval and the new interval and those that overlap with it, plus the merge interval. So we need it as a list so we can add it, and then the right that we know is smaller, right? So for non-overlap, we return this. For overlap, we return this. Now, the remaining two things we need to think about are, how do we detect an overlap, and how do we calculate left and right. I'll first start with how do we detect overlap because it's slightly more difficult. So how do we detect an overlap? Well, we decompose it into those smaller than the interval and then those bigger than interval. If there is an overlap, that means there is an interval. That means there is an interval that we didn't include in left and right because it wasn't smaller than the new interval. So the way we can check this is just if the length of these two is not equal to the length of the set of intervals, that means there were some intervals that weren't part of these two, which means there was an overlap, right? So if the length of left plus right is different than the length of the set of intervals, that means there was an overlap. So what is left here? Left is just all those that are strictly to the left of the new interval. So how does that look like? So for I in intervals is just the interval. If it's to the left of the new interval, how do we check? So if it's to the left, then the new interval would be here, right? So let's say this is the new start and this is the new end and this is the interval we are looking at. Then we just need the interval end to be smaller than the new interval start. If that's the case, that means strictly smaller, that means it's to the left of it, strictly to the left of it. And so this is if the interval, if the end of the interval is smaller than the new interval start, which is 0. What about for the right? Similar actually. So let's say this is an interval we are looking at, I, and this is the new interval here. So this is the new interval start and the new interval end. Well, we just need the new interval end to be strictly smaller than the interval start. That means it's completely to the right. There is no overlap. And so here, this would be equal to I for I in intervals if the new interval end is smaller than the interval start, right? That's exactly what we have here. That's exactly what we have here. So this is the new interval end is smaller than the interval start, and that's what we did here. Okay, the new interval end is smaller than the interval start, and so you can see the left and the right are completely non-overlapping, smaller, and non-overlapping, bigger. Bigger as in after, non-overlapping before or non-overlapping after. And so if non-overlapping before plus non-overlapping after, if the length of those is equal to the length of intervals, that means there is no overlaps. That means we are in this case. But if it's not equal, that means there were some elements overlapping, and so we need to merge. And so this way of doing it actually makes it easier because we group all the no overlap cases in one solution, right? We took the left, and the left can be empty, and we take the right, and the right can be empty. Or if it's in between, we take the left, and we take the right, and then we add the new interval. And in a similar way for the overlap case, we do the same thing where we also abstract over whether there was one interval overlap or multiple interval overlap by doing this concept of the first overlap and the last overlapping interval, right? Now, there is only one thing missing, is how do we calculate the first overlap and the last overlap? Well, we can use actually left, because let's see here. In this case that we have the left side, right? What is the first overlapping interval if there was an overlap? Let me actually draw it. So let's say this is the left set of intervals. So this would be the left set of intervals, right? And then now we have our new interval here. And then we get the right set of intervals, right? Okay. Let's actually just make this easier to see. So there are some overlapping intervals here with the new overlap. So how do we find the first overlap, which is here? So this is the overlap with the new interval. And the last overlap is this one. So the first overlap is just the one right after left, okay? And so to find it, we can just say, let's just take the intervals and take the left, the length of left, because we are indexing from 0, this will give us the first overlap. Now to find this last overlap, this is just so this is all the intervals are here. And the length of right is this, right? And so we can just take the length minus right minus 1 to get the one right just before the right, just before the first right one. That's the last overlap. And so this is our first overlap. Last overlap is going to be just intervals of the length of intervals minus the length of right minus 1 to get just the one before the first element of the right set of intervals, right? And that's pretty much it. So that's the one that we use here for the first overlap. So this would be the intervals, length of left, and this would be intervals, length of right, length of the intervals first, minus length of right, minus 1. Because it's just the one before the right set of intervals. Okay, I hope that was clear. Let's just run it on one of the examples, the second example, to make sure it's really clear. So that one we have 1, 2, 3, 5, 6, 7, 8, 10, and 12, 16. Okay, and the new interval is 4, 8. Okay, and so what is the left side? So the left side are all those smaller than, where the ending is smaller than 4. So 2 is smaller than 4, so it's part of the left side. Is 5 smaller than 4? No, so that's not part of the left side. We can start our right. So right is basically when the start is bigger than the end of the new interval. Is 3 bigger than the end of the new interval, which is 8? Is 3 bigger than 8? No. Let's go to this one. Is 6 bigger than 8? No. 8. Is 8 bigger than 8? No. So that tells us there that there is an overlap with these here, because they are not part of the right nor part of the left. Is 12 bigger than 8? Yes. So that one is part of the right side. Let's just add it here. So 12, 16. So now we have our left and right. We want to check if there is an overlap. Well, the length of left plus right is 2. But the length of the interval is 1, 2, 3, 4, 5. So 2 different than 5, which tells us there is an overlap. And that's exactly what we see here, because these were not added to the left and right, which means there is an overlap. Okay, so now we need to find our first overlap, and we need to find our last overlap, and then take the merged interval and then return it. And so how do we do that? So we need to take the first overlap. What is the first overlap value? So the first overlap interval is going to be just length of left plus 1. So length of left plus 1, that's 1 plus 1, so that's so it's just length of left, right? So it's length of left is 1, and so it's this position here. And exactly that's the first overlap. And so the first overlap is going to be just, according to our rules, it's going to be 3, 5. What is the last overlap? Last overlap is going to be the length of the right, which is 1. So the length of the intervals 1, 2, 3, 4, 5. So 5 minus 1 minus 1. The length of the intervals minus the length of the right minus 1. So this will be 3. So 2, 3, and this is actually correctly the last overlapping one. And so the last overlap is going to be 8, 10. Okay, so now we just merge these with 4, 8. And so the starting is going to be the min of the first overlap, which is 3 and 4, and that's 3. And the ending is going to be the max of the ending of the last overlap, which is 10, and 8, which gives us 10. And so at the end, we want to just return the left plus right plus this new interval, 3 and 10. And so at the end, we're just going to return a left, which is 1, 2, plus 3, 8, 3, 10, plus the right, which is 2, 6. 12, 16, sorry. 12, 16. Okay? And this is the result that we return. And if we take a look at the problem, that's exactly what we have. Okay? That's exactly what we have here. So that's with the overlap, if we run it on the overlap. If we run it on a case where there is no overlap, it's actually a lot easier. So a case where there's no overlap, let's say we have 1, 2, maybe 4, 6, and the new interval, let's say, is 7, 8. In that case, well, our left side, which is everything smaller, is going to be 1, 2, and 4, 6. And our right is going to be empty. And so when we check the length of left plus right is 2, and the length of the intervals is 2 as well. So it's equal, which means no overlap, which means we are in the second case, and we are going to return just left plus the new interval plus right. Okay, and so what do we return then in that case? Well, left is just 1, 2, 4, 6, plus the new interval, which is 7, 8. And that's it. And that's exactly what we expect. Yeah, so that's pretty much it. I hope this solution was clear. I think I chose this solution because it's pretty unique. Instead of like merging the intervals, we divide into a set of left and right, and then we merge. Yeah, so that's pretty much it for this solution. Now, if we think about the time complexity of this solution, we do this left here, which is O(n), and the right side, getting the right side is O(n). This here is O of 1. We are not doing anything extra. And this here is O of 1. So overall, it's O of n solution in terms of time. There is, though, a downside, which is the space complexity. So the time complexity is O of n. Space complexity, we are using these extra left and right lists. And so it's O of n as well there, right? So in terms of space complexity, it's going to be O of n space. Okay. Yeah, so I think that's pretty much it. Now let's implement this solution and make sure it passes test cases. By the way, just one comment. I used in the overview a black background. Just let me know in the comments if you prefer that or a white background like in other videos. Yeah, so let's get started here with the implementation. So it should be pretty easy. So let's just get started. So we need to do the same thing that we did to get the left and the right. We'll just first store the start and the end of the new interval in a variable just to make it easier. And then we compute our left and right portions. We already seen this. So left is everything where the end is to the left of the start of the new interval. Right is everything where the start is to the right of the end of the new interval. And we check if there is an overlap. And so it's just when the length of left plus right is either you can do different or you could do smaller than intervals. Then this means there is an overlap. Otherwise, if there is no overlap, then we can just return left plus the new interval plus right. But if there is an overlap, then we need to find the first overlapping interval, and that's just the one right after the end of the left ones, and the last overlapping interval, which is just the one before the first interval of the right side. So we can calculate it this way. And then we get the start and the end of the result merge interval, which is this. So start is just the min of the start of the new interval and of the first overlap starting position. And the end is the max of the end of the new interval and the end of the last overlap, right? Which makes sense. And then we could just return left plus this merge plus right. Now, since we are adding list, we need this to be a list so that it works properly. And then this else here, we can also remove it, because if we don't return, that means we are in the else case. So let's run this. Looks like there was just missing an end. Okay, let's submit. And that passes and works properly. Yeah, so that's pretty much it for this solution. Please like and subscribe, and see you on the next one. Bye.